Okay, so this we're talking about scatterplots, and scatterplots is the relationship between two variables. When we look at it, we can often see a trend or a pattern, and we can describe that using or describe the correlation. And well, I'll show you how to do that in a second. So right now we're talking about Julie, and she's gathered information about her height, age, and height. So we have age and then height there. You can see that age is on the bottom axis and height would go on the other one. So the vertical axis is our dependent variable, because height is going to depend on her age. So this is independent and this would be dependent. Now, it asks us to describe the trend. So the trend is like looking at the graph, forgetting about height and age and all that, just looking at what's happening. It's going up to the right. So since it's going up to the right, we see it's a positive trend or positive correlation, as we're going to talk about later. Now it says describe the relationship. That's when we got to use words. So I would say as the age increases, height increases. Yeah, so pretty much every time you write this, you're going to say as this thing, whatever's down here, increases, what's happening to that? So in this case, it's age and height. So it could be anything else. You could say as the time goes on, the money in my bank account decreases. So that could be a line that goes down like that. So it's always going to say as as time increases or age increases, whatever is on the bottom axis, whatever that is, you could say as that increases, then describe what's happening to what's on the dependent axis. So the independent variable is located on the x-axis, that's independent, and it does not depend on the other variable. The height doesn't depend on, the age doesn't depend on how tall somebody is. It's the height that depends on the age. So dependent variable is located on the y-axis. In this case, independent would be age, and dependent is height. Correlation, a scatter plot that shows this here is a scatter plot that shows a positive correlation. So it's a line that increases. It's not exactly a line, but it's pretty much showing a line. The two quantities increase together. Over here we have a correlation that's decreasing, it's going down. So it's a negative correlation. It goes down to the right. So as one thing increases, the other thing decreases. Now here we can see there's no clear pattern. It's kind of a jumble of dots. So this shows no correlation. Strong or weak. Correlation is strong if it forms a clear line. Now this one is getting a little bit weaker because the points are a little more spread out, but it's still a pretty good correlation. It's just not as strong. So if the points nearly form a line, then the correlation is strong. If they're more widely dispersed, then it is weak. But it still shows a correlation. Okay, line of best fit. You can read through all this. I'm just going to quickly go through it and say it has to follow the trend. Go through as many points as possible. There should be roughly the same number of points on top and below. And you should pass through points all along the line, just not just the end. So don't just point join the first dot and the last dot. So a line of best fit. The best way is to just see it. So a line of best fit isn't going to be exact for everybody. It's different. We're going to have different answers. Excuse me. It's late at night, so I'm yawning. Here I can see that it's decreasing. And if I drew a line, it would look like that. Now, what we're trying to do is get roughly the same number of dots on top and bottom. So I didn't go through a lot of points. I only went through 2 points. But if I look at the top, on top of the line, 1, 2, 3, 4. On the bottom, 1, 2, 3, 4, 5. It's roughly the same. It's not exact, but it's fairly close. So that's a pretty good line of best fit. Now yours might be slightly different, but it'll be pretty much the same thing. So here we could say that this is a negative and strong correlation. Now the next line, or the next panel here, it's not a great correlation because it's kind of wide apart, but I could see that it's still going in that direction. So if I were to draw an oval, that oval would be pointing up as we go left to right. So if I drew a line of best fit, again, I'm going to pass through as many points as possible, but I want to have the same number of dots in top and bottom. So here I didn't pass through any points, but I could see that I have 1, 2, 3, 4, 5 on the bottom, 1, 2, 3. So maybe that's not the best line of best fit. So let's try again. What you want to do is make sure you have a ruler using. And let's see now, I have 1, 2, 3, 4 on the bottom and 3 on top. That's pretty good. It's not exact, but none of this is exact. They're all over the place. So this is still a positive correlation. I mean, it still has a correlation. It's still going up. I can see it's increasing, so it's positive. But it's not that strong. Let's say it's weak. And the next one, you can see that I mean, there might be. If we kind of ignore these ones here, it could be going down. But if I don't ignore them, it's sort of all over the place. So I would say that this has no correlation. The next one here is a little strange. It's more of a curve of best fit, which we would normally do in class together, but I'm skipping it now. So this would be a curve of best fit, not the other ones. This again, next one here, E, it's all kind of jumbled and I don't really see a correlation there. So I'm going to say no correlation. At the last one, there's definitely a correlation. There's a line that's increasing. So I would do that, and that's pretty good. It's not the best, but you understand my point. You take a line, and as long as you're using a ruler, it should be pretty good. So we would say this is a positive correlation because it's increasing. And because the points are all fairly close together, I'm going to say it's strong. All right, so that's correlation. Now we are creating a line of best fit. I'm not going to do it here, but you'll see what I did in the PDF that I upload. The only thing I want to say is that if we're talking about age, I don't have anything between 0 and 25. It starts at 25 and goes up to 75, and then same with earnings. I don't have anything between 0 and 22,000, so I don't need to write everything in between. We can use a break. I can do a little break here, it's a little squiggly line, and say that, all right, start at 25. So yeah, 0 is there, but everything between 0 and 25, I'm not going to include it on my graph because it would be useless. Same thing with the money, I'm not going to include everything from 0 to 22,000, so I could say 0 to go up to 20,000 and then start from there. So if there's a large gap from the beginning, from 0 to wherever you're starting, just use that break, and then you won't have to waste a lot of your real estate on your graph. And again, I'm not going to go through it in the video, but you can see what I use it on the scale on the bottom and the top and what the graph looks like. Okay, so again, this symbol here is the break symbol, and again, once you see the graph and once you do the graph yourself and look at all these things, you can answer these questions and look at the PDF for the answers. Linear versus non-linear. So linear, easy way to say it is that linear is a line, non-linear is not a line. So if you have a graph, it's pretty easy to see. Linear, non-linear. I have a line, so that makes it linear. I have a curve, which makes it non-linear. But if I don't have a graph and I have a table of values, what we calculate here is called the first differences. So first differences are how is the y column, or the dependent variable, increasing or some cases decreasing. So in this case it's decreasing, it's going down from 200 to 175. Now I could see it's going down by 25, but if you couldn't tell, you take the second value and subtract the first value. So 175 minus 200 is negative 25. So it's negative, which is good. I mean, it's okay. It doesn't matter if it's good or bad, but it's a fine answer because it's going down. If it was going up, then it'd be positive. So don't be afraid to have a negative number here. Next, I'm doing 150 minus 175. 5 minus 150 again, negative 25. And as you can see, we keep getting negative 25. So determine the first differences. We did. It's negative 25. And what do they represent? It's that this bank account is decreasing by $25. The bank balance, or bank account balance, by $25. Is this a linear or non-linear relation? It is linear because the first differences are equal. So if the first differences were not the same number, then it would not be linear. So if it was negative 25, negative 60, negative 45, then it wouldn't be linear, it would be non-linear. But because they're the same, it's linear. Okay, so hopefully that helps you out. And